In this video, we are going to discuss the product and the quotient rules. And so these are rules for taking derivatives, and with these rules, you're going to greatly expand the functions for which you can take the derivative. So the derivative of products, so we have a function p of x times q of x, and the derivative of that function is the derivative of the first function times the second function plus the first function times the derivative of the second function. Now this is just a rule. It looks a little bit complicated, but basically you need to learn this rule in order to be able to take these derivatives. So the only way I know of to do this is some memorization and practice. So we're going to do a bunch of problems now to think about that. So we want to find the derivative, and we have a function 5x squared times x cubed plus 2. Okay, so our first function is 5x squared, and our second function is x cubed plus 2. Now in this case, it's pretty straightforward to figure out what our two functions are. Sometimes it's a little more difficult, but this is the idea. Okay, so f prime of x, the derivative, is equal to the derivative of the first function. That is a constant times x squared, so that's 5 times 2x to the power 1, so that's 10x times the second function, x cubed plus 2, plus the first function, 5x squared, times the derivative of the second function, so we've got a power rule here, 3x squared, plus 2, that's just a constant, which is 0. Now, of course, we can simplify if we choose. If I'm asking the question, I don't care about simplification. Sometimes you're asked to simplify, so let's just do that. So that's 10x times x cubed plus 2, which is 10x to the fourth plus 20x plus, and that's 15x to the fourth, which is equal to 25x to the fourth plus 20x. Now in this particular instance, we could have done this in a slightly different way. We could have multiplied things out first and then taken the derivative. Let's just check that we get the same answer. F of x equals, we multiply out, we distribute, x squared times x cubed is x to the fifth, so that's 5x to the fifth plus 10x squared. We take the derivative and we get 25x to the fourth plus 20x, which is what we did last time. Okay, our next function, g of x equals 1 over x squared times 2x plus 1. This is probably easier to rewrite as x to the minus 2 times 2x plus 1. And now we take the derivative, g prime of x equals x to the negative 2 is our first function, 2x plus 1 is our second function. This is a power rule, negative 2x to the negative 3, that's the derivative of the first function, times 2x plus 1, plus the first function, x to the negative 2, times the second function. Derivative of the second function, sorry, just 2. So that's equal to 2x plus 1 over, hold on a second, over x cubed, and we've got to multiply all of this by negative 2, sorry about that. Negative 2 times 2x plus 1 over x cubed plus 2 over x squared. I don't see that that's made anything particularly nicer. I guess I can see one thing in here. We've got negative 2 times this, so that's negative 4 over x squared. That's the first term, minus 2 over x cubed plus 2 over x squared, and so I guess that's negative 2 over x squared minus 2 over x cubed. I'm not sure that helped us very much at all. Again, we could have multiplied, distributed first, and done the derivative. G of x equals 2 over x plus 1 over x squared equals 2x to the minus 1 plus x to the minus 2, and we take our derivative g prime of x equals negative 2x to the minus 2 minus 2x to the minus 3, which is the same thing. On our last problem, h of x equals x cubed plus 2 times 1 over 3x squared. Same idea. First function, second function. Might be easier to rewrite the second function, x cubed plus 2 times, let's put the 1/3 in front, 1/3 x cubed plus 2 times x to the minus 2. First function, second function. Okay, h prime of x equals 1/3, it's just a constant, take it out. The derivative of the first function, 3x squared times the second function, x to the minus 2, plus 1/3 first function, x cubed plus 2 times negative 2x to the minus 3. In theory, we can simplify this. We can make this a little bit easier to look at, but in practice, it doesn't really matter. All right, some more functions. 5x squared natural log of x cubed. So I think I need to do some work first. This natural log of x cubed, I don't know how to take the derivative of that, but I have to take the 3 out. So we bring the 3 down. 5 times 3 is 15. 15 x squared natural log of x. Here's our first function. Here's our second function. Take the derivative. F prime of x equals derivative of the first function, 30x times the second, ln of x, plus the first function, 15x squared, times derivative of the second function, 1 over x. G of x equals 1 over x squared log base 2 of 2x. Again, we need to simplify. So g of x equals 1 over x squared times log base 2 of 2 plus log base 2 of x, and I might as well simplify a little more. Log base 2 of 2 is simply 1, so that's 1 over x squared times 1 plus log base 2 of x. We take our derivative, g prime of x, the derivative of the first function, negative 2x to the minus 3, times the second, 1 plus log base 2 of x, plus the first function, 1 over x squared, times the derivative of the second function. We learned this last time, 1 over x ln 2. We might be able to simplify a little bit. We don't need to simplify. H of x equals x cubed plus 2 times e to the x. Remember, product rule, first function, second function, h prime of x equals the derivative of the first function, 3x squared, times e to the x, plus the first function, x cubed plus 2, times the derivative of the second function. The derivative of e to the x is simply e to the x. So there we are. Okay, so that was products, derivatives of quotients. So we have a quotient, n of x divided by d of x, n for numerator, d for denominator. This one's more complicated. It is d of x, the function of the denominator, times the derivative of the numerator, minus the derivative of the denominator times the numerator, divided by the denominator squared. Now this particular rule, the quotient rule, is somewhat unpleasant to learn. Again, it's a memorization problem. You need to make sure and be careful that you take the derivatives correctly in the numerator. A very common mistake is you write d prime of x, n of x, minus d of x times n prime of x. You reverse these two terms. So just be careful with it. Okay, find the derivative. F of x equals 3x divided by 2x plus 5. So f prime of x equals derivative of the numerator, 3 times 2x plus 5, minus the derivative of the denominator, 2 times the numerator, 3x, all divided by denominator squared, 2x plus 5 squared. Now, you can see here, this simplifies a little bit. You've got a 6x in the first term minus 6x in the second term, so we can do a quick simplification and get 5 over 2x plus 5 squared. Of course, you don't need to do that step. Next one, f of x equals x squared divided by x squared minus x. The derivative is equal to derivative of the numerator, 2x times x squared minus x, minus derivative of the denominator, 2x minus 1 times x squared, the numerator, all divided by x squared minus x squared. That's good enough. You don't need to simplify if you don't want to. Clearly, you could do a little bit of simplification. You can see in this first term, you've got a positive 2x cubed. In the second term, you've got a negative 2x cubed, so those would cancel. So you can simplify this a little bit. F of x equals x minus x cubed over x plus 2. Same idea. Derivative of the numerator, 1 minus 3x squared times the denominator, x plus 2, minus derivative of the denominator, 1 times the numerator, x minus x cubed, divided by the denominator squared. And again, as always, we can simplify, but we don't need to. And for a few more functions, we have f of x equals 3e to the x divided by e to the x plus 1. So we're putting together things we learned before in the last class with what we're doing now. This is a quotient rule, so f prime of x equals derivative of the numerator, 3e to the x, times the denominator, e to the x plus 1, minus derivative of the denominator, e to the x, times the numerator, 3e to the x, all divided by the denominator squared, e to the x plus 1 squared. We could simplify if we wanted to, but we don't have to. Next one, x ln x divided by x squared plus 1. Okay, it's a little painful, but f prime of x is derivative of the numerator. Well, the numerator is a product rule. So we can use product rules and quotient rules and all sorts of things together here. So derivative of the numerator is the derivative of the first function, which is just 1, times the second, ln x, plus the first function, x divided by x, because the derivative of the second function is 1 over x. That's the derivative of the numerator times the denominator, times x squared plus 1, minus the derivative of the denominator, 2x times the numerator, x ln x, all divided by x squared plus 1 squared, the denominator squared. And again, you can see there's a little bit of cancellation in the numerator if you wanted to. You've got an ln x, x squared ln x minus 2x squared ln x, so you could simplify a little bit. I'm not sure it's worth it. Last problem, f of x equals 4 to the x divided by x plus 2. Same thing, quotient rule. Take the derivative of the numerator, which is 4 to the x ln 4, times the denominator, x plus 2, minus derivative of the denominator, which is just 1, so that's just 4 to the x, all divided by x plus 2 squared. This doesn't look like you can do much simplification. But again, we're just using our quotient rule again and again. Sometimes, like in the second problem, we've combined a product rule with a quotient rule, so we have to be careful. We have to really think carefully about what we're doing. But really the strategy is take a function, which might be complicated, with these rules, break it into functions which are easier, for which we know the derivative. And that lets us take the derivative of more complicated functions. Now I will just rewrite, so we have them, the rules that we've learned. So we've got f of x, the product rule is p of x times q of x, So for the product rule, the derivative is the derivative of the first function times the second plus the first function times the derivative of the second function. So that's one rule. The second rule is the quotient rule. F of x equals n of x divided by d of x. Then the derivative is the derivative of the numerator, n prime of x times d of x, minus the derivative of the denominator times the numerator, all divided by the denominator squared. Now, in a couple of classes, we're going to learn some techniques which will mean that if you don't want to memorize this formula, you could do it in a different way. The other way doesn't necessarily make life a whole lot easier, but you can choose exactly how you learn this. I like to know my rules, so I know my product rule, I know my quotient rule. It lets me take and intuitively quickly take a lot of derivatives.